Alright guys, so this is actually page 66, which I'm going to come back to. We're really just going to be working in this book again from yesterday. Now if you can fit the rationalizing denominator underneath that, that's great. But if you have to put it on page 69, that's okay too. So once you kind of have that in there, we're going to start on 66 again. So yesterday we talked about adding and subtracting. Today we're going to talk about multiplying and dividing. So to multiply or divide, you can only multiply roots with the same index. So it's a little less restrictive than addition or subtraction. And the way you kind of do it is same thing for multiply and divide. Anything that is outside, so outsides multiply or divide together, and insides multiply or divide together. So kind of if I'm looking at multiple numbers being multiplied, the outside numbers multiply together, and then the inside numbers multiply together. And then if you can further simplify, you should. Similarly with division, anything that's inside can be divided, anything that's outside can be divided, and then simplify more if you can. So there's a special denominator note though. Roots aren't allowed in the bottom. No roots allowed. And so we have to do this thing called rationalizing, which we'll talk about. Rationalize. Okay. So let's actually jump to page 68 now and look at this next example. So we did example 1 together yesterday. Let's look at example 2 where we are multiplying. So kind of the thing you want to think about is, can I multiply? Like, do they have the same index? And these do. So I can. Now you can multiply and make it real big. It's going to be 18 times 27. But I know I'm just going to have to simplify later. So for me, I really just think about, okay, 18 is really 9 times 2. And 27 is really 9 times 3. So I kind of rewrote it that way, thinking that I was going to square root the 9, square root the 9. But now that I see I have double 9s under here, that's really an 81. And so the square root of that is just 9. So like a 9 comes out. And I'm going to have a root 6 left. So I kind of just put it all under the root, because it is all under a root. And I times them all together. But I didn't really times, I just simplified. Okay, so on the next one, we are taking a cube root on both. So you could multiply that up and make it the cube root of 64, which is actually not so bad, because that's just 4. But if you didn't go straight to that, maybe you think of it as like the cube root of 4 times 4 times 4, and then you see you got a group of 3 that you can take out, and maybe that's the way to do it too. Okay, so on example 3, I have the same index, so I can multiply. And again, I didn't want to make that super large. The first thing that came to mind on 108 was actually 36 times 3. And then I put the 4 down here, which is a 2 and a 2. I knew I couldn't cube root the 4, so I broke it up. Now then when I think about the 36, I'm actually like, okay, that's 6 and 6, which is actually a 3 and a 2. Like, and I just kept breaking them up because I kept trying to find groups of 3. And now I finally have one because I have 3 3s and 3 2s and then an extra 2. So a 3 is going to come out, a 2 is going to come out, and a 2 will stay in, giving me 6 cube root 2. Oh yeah, duh, there was a 6 right there, and then I would have had 3 6s. Well, that was dumb, but, you know, live and learn. Okay, so here I'm taking a 4th root on both, so I can do it. So I'm going to have 10 on the outside, and then I'm going to have the 4th root. And initially I was like, oh, that's going to be 8 times 8 times 8, but that's not enough, because I need a group of 4 because I'm taking a 4th root, because 64 is 8 times 8. So then I was like, okay, well, 8 times 8 times 8 is really 2 times 2 times 2, and then 2 times 2 times 2, and then 2 times 2 times 2, which gives me 1, 2 groups of 2. So 2 2s will come out, a 2, and then another 2, giving me 40 on the outside, and I'm going to be left with a 2 in. So 4th root of 2. Okay, down here with some letters, I'm taking a cube root on both, so I can do it. I have a cube root. I don't know, that's 48, which isn't so large. Do I know the cube root of 48? I sure don't. But maybe I change that to 2 times 2 times 2 times 2 times 3. And then I got x to the 3rd. And then really I have a total of 7 y's. So y to the 7th. So I'm looking for groups of 3, which I'll have one group of 3 here. So 2 will come out. I have a group of 3 right there, so an x will come out. I'm going to have 2 groups of y's, so 2 y's will come out. Then I'm going to have a cube root of 6 and 1 y left over in. So you can see that multiplication is really just a big simplify problem. And then on this last one, we get a big ol' root with x to the 5th, y, z to the 8th. And I'm taking a square root, so we'll have 2 x's come out, 1 left in, no y's can come out, and then 4 z's can come out. Okay, so let's take a little rationalize the denominator break. So since I'm not allowed to have roots in the denominator, we need to rationalize. So multiplying a fraction by 1 does not change its value. And the expression divided by itself is equal to 1. So to get rid of a root in the denominator, meaning I have a fraction, we multiply the numerator and denominator by the root or its conjugate in the denominator. So, for example, 2 over root 3, I can't really divide there, so I simplify by rationalizing. So I would times by that same root on top and bottom. And the reason that works is because root 3 times root 3 is root 9, which is 3. On the top, one's outside, one's inside, so we just smash them up, 2 and 3. Now, if the 2 and 3 could be divided, I would divide it, but I can't. Now, maybe one that's weirder is if I'm 2 over the cube root of 3, because I can't simply just multiply by the cube root of 3, because that's going to be the cube root of 9 and I don't know it. So the way I think about this one is, really, I'm trying to get a group of 3 down here, and I have 1 3 so far. So if I put 2 more 3's over here, I'll have a group of 3. And now what I really have is the cube root of 3 times 3 times 3, which is 27, which is 3. And on the top, I can't multiply the 2 inside that, so the 2 is still going to be out front, but in that root, I might just multiply and get the 9, because I can't take the cube root of 9. And again, if the 2 and 3 could simplify, I'd do it, but I can't. Now the last sort of rationalizing the denominator sort of thing is if you had something like 4 over 1 minus root 3. So if I have multiple numbers in my denominator, including a root, you want to multiply by the conjugate of that, which would be 1 plus root 3 on top and bottom. Now really you're multiplying by 2 numbers here. So on top you're going to distribute and you'll have 4 plus 4 root 3. On bottom you have 2 numbers by 2 numbers, so you have to FOIL. So you'll have 1 times 1 for 1. Outer will be a positive root 3. Inner will be a negative root 3. And last will be a negative root 9, which is 3. And the middle terms cancel out to 0. And so really you're looking at 1 minus 3, which is negative 2. And then 2 and all the 4's are outside, so you can divide those. So you'd have negative 2 minus 2 root 3 as your final answer there. And then trying a couple of quick dividing problems back up in here on page 3. Really when you divide, you can divide first or after. Kind of like when we multiply, you can either multiply first or later. Now here I can't because the indices are not the same, so not possible. It's already simplified. But something like this, I might take the square root of sum of 20. So I would put the 2 out and leave the 5 in. I can take the square root of the x to the third, although really I have an x squared because that would cancel out, so really 1 will just come out, and then the y will come out. On the bottom, the square root of 9 is 3. The x I got rid of already, and then the square root of z to the third will have 1z out, put 1z in, and then I have to rationalize that. So I'd multiply by root z on top and bottom. And so I'd have 2xy 5z all over 3z squared. One more to maybe try here is something like number 4. I wouldn't worry too much about 3 and 5. For now, we can talk about those. But I'm taking the 4th root of this, and I can take the 4th root of 81. That's 3. The 4th root of m to the 4th is m. The 4th root of 16 is 2. And the 4th root of n to the 8th is n to the 2nd. So that's kind of how something could fully simplify, which would be super nice. So hopefully that helps, and try your best, and yeah, good luck.